Welcome, everybody. We're going to be working on our Unit 2 materials tonight, and we're going to be going through this PowerPoint to hit on all the topics. These are our main topics for the evening, or at least for this unit. All right, because we were covering Unit 1 just before. All right, so we're going to look at how data is really important for AI. We'll look at like what limitations AI has, and some of it is, due to technology or lack thereof. And then we'll also start to look at all these disruptive technologies or emerging technologies, if you will, that are transforming things and allowing this revolution to happen. All right, so we're going to talk a little bit about data, because this, is really an important aspect of working with AI. If you're going to use especially generative AI, or if you're going to use AI that relies on data to make decisions, you have to start asking some real fundamental questions about it. And this is why this topic fits well with the data analytics topic, right? If you guys haven't figured that out, why we have a combo degree, AI data specialist, right? So you ask this big question, why do you even collect data? And human beings, even a very long time ago, figured out, you know what? I went out hunting, I killed a couple of deer. I'm going to draw a couple pictures of deer on the cave wall, so I have a memory of, like, I had that one, the great hunting trip where I got a couple of deer, and keep track, right? Or, maybe you find a way to figure out how to write it down, right? And this is one of the interesting aspects of human history, because it's not that humans didn't know how to read and write before what they're pointing out here, but when they would write stuff down, and let's say they would write it on paper, what's the shelf life of paper? Not that long, right? What I thought was really clever about, this approach, so we're looking at basically the Sumerians and around 3000 BC, right? So that's 5,000 years ago. And that kind of blows my mind, right? That 5,000 years ago, these people figured out, hey, you know what? We got to keep track of, like, what stuff we have, how many animals we have, how many things you made, how many people we killed, how many countries we conquered, or whatever they're trying to count. And instead of writing it on paper, they would take these little, they call this cuneiform, I believe. They would take these little clay tablets, and they'd have these specialized like writing utensils, were really kind of like tools, right? And they would make impressions like this into the tools. And this is a combination of a language and a number system that we're seeing here. And data analytics one people, notice how spreadsheet like it is. rows and columns, right? Like, oh my god, even back then they were organizing their data in a tabular fashion. But what's fascinating about this is they would impress this into clay, and then they would fire the clay to make it into stone, like brick. And oh my god, those tablets survived like 5,000 years. Like, talk about a brilliant storage mechanism. Because one thing that we'll learn about is, like, how do you store data and keep it fresh for a long time? All the mediums that we use to store information are not forever mediums, by the way. So this is a really clever approach, right? The fact that they could track things by doing this gave their society a really distinct advantage over a lot of the other societies that were around at the time, because they were able to keep records and refer to their records and go, hey, how many bales of corn did we, or how many bales of wheat did we have last year? Oh, we had 500, and they would have a count, and they could do calculations with it and figure stuff out. So in the more modern era, right, and I say that tongue in cheek here, because this is a picture of what computer system that we're looking at. I think it's ENIAC. It's either ENIAC or the Mark IV or something like that, one of those old machines. Notice the vacuum tubes on top, right? Those are in place of transistors and, the patch panels and everything. But kind of interestingly, we got into like the commercial computing era. We got past the 40s, and generally either big business, government, or scientists or universities would have computer systems, and they would start to generate data, and then they wanted to store the data so they wouldn't lose it. So back in 1957, the US government planned the very first data center, right? And they would use magnetic tapes to store the information. Notice the lifespan of those magnetic tapes, at least at the time, 10 years. And very interestingly, we've been hearing this for a long time, right? Like if you record stuff on magnetic tape, so I don't know if you guys still have your 8-track collection or your cassette collection. You know, I still have my entire cassette collection, and I always remark at the fact that, oh my God, most of these tapes still work just fine. Um, yeah, well, I probably kept them okay or something, but in principle, they don't have a very long lifespan. And that kind of blows my mind. So, like, in other words, they have these magnetic tapes and they're storing all this data, but they're only going to last 10 years. Then what happens? Think of those clay tablets now lasting 5,000 years. That's a pretty impressive feat. It's way better than our magnetic tape, right? So I think that's kind of interesting. So why are we collecting data today? Well, for a lot of different reasons, right? So here's some examples. We use a lot of data to drive computer models just to predict the weather. You know, I always felt that Albert the Alley Cat, if you guys are, old people, if you guys remember that, on Channel 6, we had an old weatherman. He had a puppet that would tell the weather with him, and he would like probably just guess half the time, and he would probably get it more right than some of our weather models. But they have gotten really good at predicting temperatures, weather events, severe weather, and all that kind of stuff. But there's still a lot of variance. But weather prediction is huge. Facial recognition, wow, right? I may have mentioned this before, but I did some AI training with the security guy from the Canadian government, equivalent to like Homeland Security, and they use real-time facial recognition in their airports up there to look for terrorists, right? Uh, Weird, right? Sounds like sci-fi, but no, this is like stuff that's been in place and being used for quite a while. Also, to understand language, that's probably the biggest growth area right now. I want you to be mindful of all the links here too that point to the data. If you guys want to read up, just follow those links. All right. So, what's changed over time? Well, I mean, we've had a lot of technology that's happened since then, right? Um, Electricity, different types of mathematics and whatever. But we've had a technological revolution, and it's been going on for a while. But it's really the 20th century where it all exploded, right? Um, you guys remember back to the Python class where we did a whole little spiel on computer history, and we did look at the abacus and the Antikythera mechanism, and then we looked at the Jacquard loom, right, to store information on punch cards, and then Charles Babbage and his analytic engine, which became the fodder for IBM Corporation, and then we had electromechanical computers, and then we had ENIAC, and then we had vacuum tubes and transistors, and voila, Skynet, kind of like that. But yeah, a lot's happened. So we have, instead of like a room full of vacuum tubes and cords and switches and relays and stuff, we have like a billion transistors on a chip that you can fit like on your fingertip. Insane, right? We have the internet. Everything's connected. We got wireless internet. We got wired internet. I mean, we got satellite internet. Oh my God! Like we have the internet in our pocket everywhere we go. And then we have these supercomputers in our pocket, right? All of these things qualify really, if you think about the world that was before these technologies were here, these are all disruptive technologies. They just completely disrupted what was happening before and changed the world completely, right? And I would say that none of us can operate without these technologies on the screen right now. All right. I'm going to skip the questions if you don't mind, but I love this quote. And it says, information is the oil of the 21st century. I want you guys to ponder that really deeply because I think this is a really profound statement. And analytics is the combustion engine. So we have all this information. What are we doing with it? We need to analyze it and figure it out because it is telling us something. We generate so much data, there's value in it. Well, the principle is that we use the data to train the AI models to make the right decisions. Now, we have these like goofy robots here, and this is one that's like doing a backflip, which is really pretty amazing. What's really strange is if you guys ever visit the IMET Center and go to an area called the Sim Lab, which is right next to the data classroom, we actually have a robot dog on campus now. Have you guys ever, anybody ever seen it? I'll have to have David share a video with me. But we have a dog, and he's trained it where it can follow him around campus, and he can tell it to sit, stay, beg, you know, all sorts of crazy, and it does so autonomously. Right? I would not say it's AI driven; it's just got really good software in it, but it's here, folks, right? And Gateway can afford to have one on campus. It's not really even that expensive. All right. There are limitations, though, to working with AI. Um, and a lot of them are based upon technological restraints, really, right? So some of it is okay, the first bullet. Okay, we have this like AI model, but in order for it to really be informed and make the right decisions, we have to give it good data. We talked about this before. Like one of the issues with generative AI, at least the free public facing generative AI, yes, it's very amazing, can do really cool things, but it only has access to the surface level data of the internet, right? We talked about this before too. Like when we go out on Google and we do a search, we're searching maybe like somewhere between 3 and 5% of the total content that's on the internet. Most of the real content is behind a sign in or a firewall or inside of a system that you have to have an account on. Now, if you get a paid version of generative AI, and if that generative AI supports it, where you can give it your logins and passwords, because people do that, and it has access to all the same stuff that you do, all right, well, now I can run Gen AI and ask it to run an algorithm to see like which one of my friends are, you know, yada 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 on social media, right? Because I can get into my account and look around, right, and save me the time of doing the same thing. Should I unfriend or unfollow, or maybe I shouldn't befriend those people at all? I don't know. There's also the bias thing, right? And this unfortunately is sort of a human factor because us humans, um, well, first of all, we like to lie, right? We also have strong opinions because of how we were raised or how poorly we were raised or what, you know, ideologies we were trained with, right? And unfortunately, um, the people building the models and the people feeding data to the models sometimes feed biased information. And it's unfortunate, but it is part of the situation. Um, there's also the computational time. So it's like no matter how good the CPUs are, you know, you can bet like these new GPUs that are coming out, these like whatever series they're even calling them, I don't even know. Um, People are going to clamor for them because they want that computational power to increase the processing rates to make the AI work better, right? That costs money though, right? Um, you know, high-end chips are expensive. They also typically take more power. They generate more heat, et cetera, et cetera. And then we also have this thing where, you know, okay, so now we're generating all this data and using all this data. And if we're generating even more data with the Gen AI, we got to store it. And this is why you're hearing all these stories right in our own backyard. Microsoft's building a data center. Wait, they're going to build another data center. Hey, wait, they're going to build another data center. And it's not going to stop, right? And they have to plan for 10, 20 years out. They're predicting exponential growth. They wouldn't be buying up land here if it wasn't coming, basically. Um, we also have to have data that's usable, right? So like, so in other words, um, not all data is created equal, so it's all in how it's collected. As we will discover, like in the data analytics class, sometimes you get like a data dump from like a database or from a sensor or something, and the information you're getting is corrupted or incomplete, or some of it's missing, or if a human entered it, they didn't enter it correctly, right? So there's quality issues when we interact with humans that are biased. Yeah, we don't always tell the truth. Yeah, how many cats do you own? Just one. Nobody wants to admit they have 5 cats, or 10 cats. Some people do, right? So people lie. Um, we also need to have a lot of data coming in to train the models. It's not always easy to get. That costs money sometimes. So if you want to train a model well, sometimes you got to pay for the data. Remember that slide. Data is like the oil of the 21st century. It's the commodity. It is. Data has value, and by the way, it costs money. And so when you're on the internet, I'll have you think about this, and you're using Google for free. What's the cost of your free account? Your information. They take that information and sell it to others, folks. What you're surfing for, what products you buy, who you're communicating with. You know, if you got like a smartphone and you're driving around, the location data is sold to the insurance companies. And so when you say, hey, I never drive to work anymore, and they're like, but you're driving 300 miles a day. Google shared the information with us. It's part of the terms of use, right? You got a free Google account, right? So yeah, very weird. And the last bullet's a pretty important one too. That's like, when companies do collect data. So like if you have a big insurance company and they have all this data, they're not going to try to share it with the other insurance companies. Or if they do, they're going to ask really, really big money for it. Right? It does have value and it belongs to somebody. The bias issue is huge. So we're seeing this a lot. So like we're seeing AI used like at insurance companies to make determinations on whether a claim is good or not. How do you think they're going to slant that one? Right. Any way they can so the insurance company doesn't pay. Right. Or and they're saying like areas such as hiring, criminal justice, and healthcare. Now, I just recently wrote a letter of recommendation um, for a couple of students, and one student also gave me a resume, and I gave him a couple of tips on it. And I'm like, you know what? If you send in this resume, you're not talking about any of the actual skills you learned at school. You're just talking about like you got this degree. You need to put on your thing like, hey, I know Python, I know R, I know Tableau, I know Excel, etc. Because chances are the company that's going to hire you is taking all the resumes, feeding them through an AI to filter out the ones that don't include that information, right? So you can kind of like work it a little bit if you're clever about it. Um, I think this is kind of interesting. Models can be trained on data containing human decisions as well as data containing second order effects of societal historical inequities. So, in other words, we can train it based on what we're doing as opposed to what has happened. This is kind of interesting. I think that the bottom bullet is troubling, right? Because an AI model is 10 times more likely to identify African American male as a criminal than a non-African male due to underlying data bias. That's terrifying to me too. Just because data says one thing, at you know, um, and keep in mind there's bias that incarcerated those people in the first place, right? And so this is something we have to be really, really careful with going into the future. And I think one fear that a lot of people have is that we can't, like, if we're using data sets that started out with a bias and we're training an AI, that bias is going to be built into the future, and that's horrible to think about, right? I think it's terrifying, actually. Computational time and cost says like even training a simple AI model on a traditional PC might take a few days to months, right? Um, so if you don't have the right gear, basically what they're saying, you need some high powered stuff to do AI when you start crunching the math on it and when you're feeding it big data sets, right? Um, And there's huge costs that go with that, not only for the hardware, but for the time involved. But if you set up a model and it's got mistakes in it, okay, that's a problem too. This is a really concerning problem that's been around for a long time. So like whenever we would look at like operations science and management classes, right, we would build math models to model like the cost of carrying inventory in a warehouse. You know, like what does it cost to keep a box in the warehouse? You know, that kind of thing. There's a cost, you know, because you have to have the shelf, you have to have the person that puts it there. You might have to heat or cool the space, or you keep it there for 6 months before you sell it. Um, those models can have flaws in them, and if the models have flaws, so the math is wrong, well, then it makes the output of the model wrong too, right? So you have to create models mathematically that accurately represent the real world. Pretty weird, right? So it takes really high level um, scientists, actuaries, engineers, and mathematicians to kind of get that stuff right, right? Um, and let's face it, how many of us even want to study that stuff? Not a lot of us. Now let's take a look at the data, and we're going to introduce this new concept that we're going to call synthetic data, and this is, I think, pretty fascinating too. So we're training Gen AI ideally on real data, right? Okay, great, that sounds good, right? So if I want to, like, for example, create a piece of music with a Gen AI, it's helpful for the Gen AI to know what music has been before so it can recreate it, right? Or copy it or build upon it. But because we don't have a lot of data sometimes to feed an AI, or it's really expensive to feed it, sometimes we use AI to build data to train our AI. Got that? Right. So we're generating not real data, right? And then we're using that not real data to train the AI under assumed realistic conditions, right? So I think this is really kind of an interesting aspect of Gen AI. And, you know, I kind of go back to my example from my training from last year where we were building an app and the instructor said, well, don't type up all that data, just have the AI create you some sample data and just use that to see if your app works, you know? And in this case, we would take the data that's created to just simply train the AI. I think that's pretty weird. Very, very weird. The fact that we're using synthetic data um, creates some possibilities for businesses. So if they don't have, like, so for example, if you're going to train an AI to work with some of your stuff, whether it's like a robot or, you know, a piece of software, and you don't have real world data to feed it, and you can generate the data to train it, then you can, once it's up and running, you can adjust it to real data that will hopefully, um, you know, be an accurate representation of the real world. And this is a thing you're going to hear over and over again, because we're building models, and models are representations of reality. They're not reality, right? So it's on us and the designers of the Gen AI to build the models that are real world like. And if you're going to generate synthetic data, that also has to be real world like. How do you get that? Well, you might have a couple of case scenarios, and then you imagine some possibilities and you throw out some scenarios, and you hope you're close. You know, if you're generative from scratch, you really don't have much control over it. Right. So I think that this is really kind of an interesting concept, because I would speculate that we've all heard about data, but we've never thought about synthetic data, you know? So what if they start to write algorithms based on synthetic data and then try to apply them to us to control us, and that data's off? Well, that's kind of an interesting thought. Um, the thing that I think is pretty fascinating is now they're starting to apply it to, you know, more tangible things. So look at some of these some of the acronyms here. I think these are pretty interesting. So generative AI, specifically generative adversarial networks, can be employed to generate realistic synthetic sensor data. So in other words, um, creating stuff that isn't necessarily always perfect, right? Because not everything in the real world is perfect. Sometimes there are flaws in the data, so you have to reflect that in the data that you're building. Um, using synthetic data, especially in sensor-driven applications, um, can really help to accelerate the building of things like autonomous vehicles, which we're going to look at here in just a little bit. Yeah, I'm just looking at the highlights in this first bullet here. It says that it can help bridge the gap between simulated and real world data, right? And I'm still going to argue that you need like real data to build from, or at least within a range before you start to generate it. Um, when we start to like actually look at how autonomous vehicle work, and we're going to see a few videos here in a little bit, I think a lot of it is really kind of intriguing because some of it is driven by cameras alone. So they have cars that self-drive and just use cameras to figure out where they're at, right? And sensors in the car. Other autonomous vehicles will use things like LiDAR, you know, so kind of like cameras and reflectivity. Others will use sensor data. So in other words, like whenever you drive through an intersection, and I'll challenge you guys to do this. You drive through an intersection that has lights, like any major intersection, look up at the light poles. Look at all the sensors, cameras, lights, and doodads. I mean, they have like a complicated computer network running most intersections for traffic now. A lot of those systems feed real information. Like when you GPS something and you bring it up on your phone, how does it know which way is faster? How does it know where the traffic jams are? Well, there's sensors that are picking that stuff up. Um, once again, this is a focus on synthetic sensor data. Um, so they can take real world situations, generate some synthetic data, train the models, hopefully, and hopefully increase the rate of the development. But ultimately, the real data is what's going to be most important. All right, let's move on. We have some disruptive technologies that are coming down the line, and one big one that's happened, it's already fully in place. It's still growing. It's not everywhere has 5G, but most major metro areas do. Um, when 5G came out, it had extremely higher bandwidth capabilities than some of the preceding technologies, like 4G and 3G in particular. Um, I'm not sure what the actual rate of transmission, how much faster 5G is. I think it's dependent. But one really important aspect of 5G that refers to the frequency range that it transmits on. Um, it transmits at a higher frequency. And unfortunately, if you take those higher frequencies and broadcast them at the signal strengths that we used to do the old technology, they can, in principle, be harmful. However, if you, instead of having one big tower, have a lot of little towers, and that's how 5G works. Uh, they have lots of little towers that they're putting everywhere now. Um, it's kind of like having a router in your neighborhood. Um, that's kind of the new approach. It's not everywhere though. 5G is not everywhere. Don't believe me? Take a drive out west, right? get past like Fargo or St. Louis or something, and start heading out on the highways, and you're like down to 3G or uh, horrible signals out there, depending on your provider, of course. But in cities like where we live, Milwaukee, Racine, Kenosha, Chicago, along the interstate, 5G is pretty much everywhere. Very kind of interesting little things that are happening with it. They talk about like the transmission capability of 5G, and we need that level of data transfer in order to enable self-driving cars that might need to GPS themselves. I think it's like really fast data, right? It's like you don't have a lot of time to make a decision if something's in your pathway, so fast signals, very, very important. 5G has already made a huge impact And one area that I think a lot of people don't know about with 5G, and this was complete news to me, once again, in our data classroom at IMET, um, we have a server rack that sits in the sim lab. So if like you're ever in the classroom there, you can look through the glass doors, and off to the right is a server rack, and we have all our data analytics and web servers there for the IT programs. In that rack, we also have data feeds coming in from the industrial robots at IMET. They have a whole bunch of them. I don't know if you guys are aware of that or if you've ever seen them. And those robots over either a wired or wireless network are sending data feeds back to the sim lab. And then David Agwire, who runs that lab, has a bunch of monitors up on the wall that take the data feeds and show like this robot's up, that robot's down, here's the productivity level, yada, yada, yada. You know, all the metrics are up on the screen. Some of the robots, and a good portion of the FANUC robots, the yellow ones basically, they don't use a wired network connection. They use a 5G local area wireless connection. I never knew this existed. This is really a trip. So they have a mini 5G access point. It's not like a Wi-Fi, router or something like that. It's a 5G access point that sits in our server rack. So we don't have to wire anything. It uses that technology because that technology is faster than Wi-Fi. That router was given to us by Foxconn Corporation, by the way. It was a prototype when it first came out, so we had one way before other people did. And there was a few reasons for it, mostly the industrial robots, but also because they're running an autonomous vehicle program in the city of Racine. I don't know if you guys are aware of this, but the city of Racine built this thing called the Badger bus. It's an electric bus. It's housed at our downtown campus. The reason they put it there is because the downtown area of Racine was one of the first areas in Wisconsin to have 5G cellular service. What a trip, right? And the autonomous vehicle is in the garage bay next to the welding department in the first floor or the ground floor of the technical building. Um, I don't know if that project's still moving forward. My understanding is they're kind of shelving it and they're looking at different technologies. But the city of Racine is looking at public transportation on a small scale with autonomous vehicles for the future. That's one of their goals, right? All electric, self-driving, affordable, clean, yada, yada, yada. All right. So AI, or excuse me, autonomous vehicles or AVs, right, is a thing that's happening. There's already vehicles out there that can do this, by the way. In some states, I think like California, Arizona, Texas, I think have already, maybe Nevada also allow autonomous vehicles to drive on their streets. So in other words, like you call like an Uber or whatever, and a car pulls up with no driver and you get in, you tell it where you're going and it takes you there. And hopefully it doesn't crash, right? Some of those vehicles in some states, they allow them to drive, but only if there's an actual driver sitting in the seat. I did have you know, I'll call it the pleasure of visiting the Tesla factory in Reno, Nevada, a number of years back when we were first looking at building these programs. We went out there to see their factory, to see the vehicles. Part of the tour, by the way, was taking us out in one of the self-driving cars on the interstate there. It was really, really freaky, you guys, right? So this guy's like driving. He's like, all right, I'm going to go autonomous. He let go of the wheel. And he just like turned around and started talking to us. I'm like, oh my God. And the car was like passing and slowing down and speeding up all on its own. It was really, really freaky. And then last year when I was going to my training, I rented it was a pretty new Toyota Camry that wasn't self-driving, but it was almost self-driving, right? Set the cruise control, it slows down, speeds up automatically, depending on traffic or the speed limit. I can let go of the wheel. It had lane correction, so it would like turn around corners and stuff. Yep. Didn't like it. After like about 30 seconds, it would start to vibrate and make all these noises like grab the wheel, but it could do it. And we don't even call that a self-driving car. But oh my God, the technology is there already. It worked really, really well. I was completely blown away by it. Right. I always make a habit of not buying brand new vehicles. So most of my vehicles are like 15 to 20 years old because I just don't want to make a car payment, I'm a cheapskate, My Toyota keeps running, so I keep running my Toyota. Um, but I want you to look at some of the metrics they say here. So the autonomous vehicle industry is expected to grow to a $35 billion market between 2022 and 2030. Whoa, right? That's right around that's 5 years away, right? 5 years away. And then by 2035, they're anticipating widespread adoption, right? So no wonder my kids didn't learn how to drive. No, they learned how to drive, they just don't want to. It blows my mind, right? Uh, right. So this will be one of those disruptive technologies, big time. Another disruptive technology, a really major one, is IoT. IoT is basically, and I'm going to see if I can find a little Raspberry Pi here, which was floating by my desk somewhere. Here it is. I have it hooked up right now, but I can't show it to you on camera. I know this is small and I'm up in your corner here, but this is a Raspberry Pi. It's about the size of a credit card. It's a full-blown computer system. This is an old one. This is a Model 3B or something like that. I think they're up to Model 5. It cost me a total of, I think, $25 when I bought it. It needs a 5-volt power supply, a micro SD card is a hard drive. You can hook up HDMI, USB, Bluetooth, uh, eighth inch audio, yada, yada, yada. But it's a full blown computer system. And a Raspberry Pi is kind of a classic example of an IoT device. So something this small is a full blown computer system. Now I can take this full blown computer system that fits in the palm of my hand and put it inside any sort of device that is equipped with sensors, motors, and other logic circuits, like a robot or an HVAC temperature sensor or whatever, and do all sorts of crazy stuff with it. It's networkable, so the data from whatever this is hooked up to can talk to the other stuff that's hooked up to the network, share that information. And oh my God, once again, this is a disruptive technology. I think the IoT revolution has maybe leveled off a little bit. Now it's just kind of like seen as a given. And I'll give you an example. I had an old dehumidifier here at home, started like not working well, started leaking. I tried cleaning it and all that stuff. I'm like, you know what? It's time for a new dehumidifier. So went to Costco, bought one off the shelf, open up the box. I didn't even read the specs on it. I just bought it from Costco because it was cheap on sale. And oh my God, it's like it's got an app and I can hook it up to the network and I can like be at work and see if it's full and then hit the little pump button and make it discharge the water. It's like, oh my God, there's IoT devices built into my dehumidifier, right? What's next, right? So many of the appliances that we're going to start buying are going to be coming with apps now. Why? Because it's so cheap to do it. If it only costs $25 for a Raspberry Pi, and that's a full computer system, I don't need a full computer system to put in my dehumidifier. I just need a couple basic chips. But the point is, it is there already, right? IoT is there. We're going to see it everywhere, and you can see some of the things here, and I like the metrics here. So IoT has increased from 13% in 2014 to 25% today. The worldwide number of IoT connected devices is projected to increase to 43 billion by 2023, already past that, and almost a threefold increase from 2018. Oh my God, you think that's stopping? It's not stopping, right? It's like, go away. Another big disruptive technology is what we call big data. And all this stuff that we're doing, we're generating more data because we have all these devices. We need more spaces to store them. And then we got to process that data. But look at that middle graphic. Big data is expected to increase the revenue of healthcare, transportation, and retail sectors by 100 to 150 billion dollars because they're mining that data to upsell you or to sell you a product that you probably might need. Oh, hey, you bought a computer. Would you like a spare hard drive? Or you bought whatever. They tie that stuff all in folks. Um, big impact from those disruptive technologies, and the disruptive technologies are really the ones that change the future. Remember, I like the integrated circuit, computers, disruptive technology, the internet, disruptive technology, cell phones. I mean, I think about cell phones. The first true smartphone wasn't until 2007, 2008, right? The iPhone. In less than 20 years, we have almost 100% adoption. Heck, kids are in like grade school and they have like smartphones. Crazy, crazy stuff. All right. Let's talk more about these autonomous vehicles, because they come from like, science fiction imaginations, right? So here's a classic, right? There's the Herbie, the little beetle. Did you guys ever watch that movie as a kid? Old people, yeah, right. That was a classic movie back then. But it was a car that had a mind of its own and a personality and had feelings and all that kind of stuff. It was very amusing, but it was, it was just kind of, a joke. But then you also had like the Batman movie. Do you guys remember that one? Or I think the Avengers one is probably the one that resonates the most, right? And Iron Man, whatever, had Jarvis and whatever, but also had a smart car as well. And they talk about these eras here, right? Like like Herbie, the beetle was kind of like supernaturally powered, that it was like embodied with the spirit or something. There's no, I mean, if you guys ever owned a Volkswagen Beetle, you know how primitive they are as an actual machine, right? And it's one of the beauties of that machine is they are so primitive. Of course, there's no heat and no radiator and whatever, but they always run. You move into the more modern era of science fiction, and they show, like, for example, the Batmobile and the tactical response vehicle from Time Cop. I do not seem to remember that one, but I do remember the flying taxi from The Fifth Element. If you guys ever watched any of those movies. Surprisingly, of course, people are smart. Back in the 20s, there's this guy named Houdini, and I don't think it's the same Houdini that did the magic stuff or the escape things. But he was an engineer in the U.S. Army. He designed a radio-controlled car back in the 20s. I'm like, okay, this is kind of interesting, right? So people were thinking about this stuff. It's like, well, okay, we got radios, we got cars. Could we put a radio in the car so I can like control it from here? And okay, like we know that like RC cars, like like little toy ones, are totally a thing. You can buy them for your kids, right? But yeah, the thought's been around for a while. So if you can radio control a car, and they were doing it way back then, oh my God, now we just have to put software to it. Interesting, right? All right, so what does this exactly mean? All right, so I'm going to flip on the video here, but it's basically capable of seeing and sensing its environment without humans being involved. The passengers in the vehicle don't have to do a darn thing. It can do everything on its own. It's kind of weird. I'm going to click on the video. What I will tell you is that I don't know how it's going to deliver to you. I have the video optimization for streaming thing turned on in Zoom. I'm going to refrain from going full screen on it on purpose. But if anybody's having a problem hearing it, seeing it, I'm going to turn on closed captions and all that. Just throw something in the chat or just speak up.
With automated driving, we are taking our core capabilities of visual understanding to the next level, where the degree of details required to support self-driving cars grows by leaps and bounds. In addition to preventing collisions, the system must sense the road at great details, including lane markings, curbs, barriers, obstructions, recognize a large vocabulary of traffic signs and traffic lights, and be fault tolerant to a degree unparalleled by today's driver assistance systems. But the greatest challenge is to have it done at cost levels that drivers can afford. Many studies have shown that customers interested in hands-free driving capabilities, but are also very sensitive to costs. Cameras are low cost and generate a very rich source of information about the scene. The challenge is to extract from the raw data the information of interest, but this is our core competence. We have introduced visual understanding functions for active safety that no one before us managed to do. We have full confidence that we can take the next step and be part of a real revolution in the way we drive. We see the technology being introduced in 2 to 3 phases. In the 2016 timeframe, we expect to launch hands-free driving capabilities designed for highway conditions, like the type of driving we're having now. To the best of our knowledge, country roads, lane changes, and city traffic will be introduced incrementally over a small number of years. We are at an exciting time in the life of Mobileye. With the help of regulators, the active safety trend is to become standard on most new vehicles, and most importantly, hands-free driving is going to transform the way we drive.
Yes, because I can take a nap while I'm going somewhere, right? Uh, Reactions at all? Yeah, yeah, it's weird. And you know what?
I don't like it. I don't like it.
Yeah, that's kind of, that was my initial reaction, but when I tried it for myself, like, I did that, Toyota Camry that I told you about, which is basically, on the highway, it was fine, right? Controlled the speed just fine, kept me in the lane just fine, all of that. Um, I can see that it's not really that far off, but highway driving out on the open road when there's not a lot of traffic, that's pretty easy. It's the easiest kind of driving to do, right? Okay, put them in downtown Chicago during rush hour with construction and throwing St. Patrick's Day or something in a snowstorm, and let's see what it's like. See how it does. A couple of bike lanes
Yeah,
or
I'm even thinking about
potholes.
like I'm thinking about the future, like the younger people in the future, if they go for a job and they're like, you have reliable transportation, and they call in these cars to get back and forth to work. And what if the car, makes them late or something?
I
Like they're
I
relying on it.
yeah, I live in a neighborhood right now where a large number of the people that live around here don't have cars.
Uh,
We used to have to fight for parking spots here on the east side, and it's changed. So many of the young people just ride scooters, ride their bikes,
oh,
or call Uber. Like, it is just so bizarre. It blows my mind.
The only thing that
Um,
scares me, I'm sorry to cut you off. The
no,
only
no,
thing that
please.
scares me is your car can get shut off. Hackers and all that
mm,
kind of stuff. I get scared about that. Like, I mean, yeah, it's a computer. It can be hacked. Someone can step down on that acceleration up to 120 miles an hour, and if they programmed it right, you're shit out of luck. I'm sorry, you're out of luck.
Right. I'll try to filter that out on YouTube. No,
Very sorry about that.
it's okay. It's not that bad, but I appreciate you catching yourself. I think this is really kind of weird too, this little graphic on this slide, and I would implore you guys to check this out on your own. But they're talking about like the levels of driving automation, and I'm going to say the vehicle that I drove was probably crossing the line from 2 to 3, but the Tesla vehicle that I got to sit in, which is a Model 3, by the way, if you're curious, like a preview model of it. Um, it was full on number 5. It could do all of it on its own without you touching a thing. You just GPS where you're going and just let go and let it do its thing. I It is very, very weird. A lot of us already have in our cars, and I want you to think about this. We have backup cameras, right? Some of us have forward facing cameras too. We have these little sensors in our mirrors that show us the cars next to us, right? We have cruise control. A lot of those cruise controls can auto adjust. We have automatic braking. We have lane correction. And these are becoming very standard features in like mid range cars, right? You don't even have to get an expensive car to get those features. Um, so we're getting there, and we're getting there really, really fast. Um, the one point that they're making here is that these vehicles do rely on their technology and whatever that technology happens to be. So they have very complicated um, computer algorithms that drive them, the software. They have sensors that are either visual or electronic or LiDAR or whatever in them. And I like these little graphics that they have here because it shows like, you know, they have to have the computer power on board to do this kind of processing, right? And for anybody who's kind of in the know of like what it takes to do that kind of processing, it's not going to be my Raspberry Pi. Basically, it's going to be like some pretty high end processors. So you're going to be looking at vehicles that have not like one computer in it, but probably dozens of different computer systems interlinked just within one vehicle. Crazy, right? Um, this is kind of an interesting one too. So they're looking at this company Mobilize um, driving on the streets of Munich, right? So it's kind of interesting. Like a lot of this stuff is changing. And we'll try to kind of, so they have examples. I think I can turn the music down. So watch the person turning around. So this is like in an urban landscape. So they're negotiating around parked cars or cars pulling out. They're making turns in traffic. And so you can see the camera views, the in-car view, and same screen that we're seeing here is also showing up there. So what exactly the tech is, I think this is kind of interesting. So highway lane changes. Okay, so that the Tesla car did that while I was. They didn't do like city driving with the Tesla car, but here's an example of driving through congested streets. I think this one was kind of interesting, where it's navigating around an ambulance and a police car. And I don't know if you guys are noticing, but this is like really happening, right? It's not like a simulation. So this is tech that's already here. What a trip, right? Moving on. Just to let you guys read these slides instead of reading them to you. There are a whole series of videos in this slideshow, by the way. You know, and I don't know if we're going to make it all the way through this, but we're making a noble effort to try to do it. You know, Gen AI is helpful in this scenario. Once again, you know, we think about synthetic data for training the models, and that's really what this slide is about. And you can also use, think about this, right? If I want to train a model, like what to do if it's going to get in an accident, I don't want to actually smash up the car to do it, right? So you just do it with the software, but you can program the scenarios in to make it happen. I think this is kind of interesting, like that kind of scenario, right? So here's like, what do you do in that scenario? What do you do as a human being in that scenario? Yeah, good, really good question. Notice that this is a NVIDIA thing, right? So this comes from, you know, once again, Wisconsin roots in a way. So check that one out. And I think that this is kind of an interesting little kind of thing to talk about here too. They have what they call the Strive method. So they have ways to generate some pretty realistic scenarios that are actually putting in there. This is the kind of same thing they do with pilots, by the way, right? They put pilots in flight simulators before they give them a plane, you know, and pilots that have to go into battle get simulated battles they go into before they actually get into a real one. And these developers are basically working on solving all of these problems. Once again, we're still focusing on the synthetic data piece here, right? And the fact that Gen AI would be used to generate that data to create the scenarios to allow us to train our models as well as possible. You know, there's a lot that goes into that. I'm letting you guys kind of read the information on your own, but the Gen AI is the big tool in this space. The one thing that we have to kind of consider, and this is the thing I was trying to mention before, is that we have to understand that real world scenarios are sometimes can sometimes be really weird and anomalous. We have to be able to program that in to including weird or difficult events. Those are not ones you want to see happen, but they do happen. Um, I was having this whole discussion the other night. We went to Chicago to see a show, and the people we were driving with, we were talking about all of the worst accidents we saw on the highway. And there were some pretty weird ones that people were talking about. And how do you, I mean, those are all fodder for training an AI in my mind. Right. Um, all right. Once again, I'm not going to click on this, but I think if you guys want to explore this one, this is pretty interesting. They have a whole little thing here about Intel driving garages and crowdsource mapping. So now let's take a look really quickly at IoT. I am going to play this video.
By now, you may
I
have
might skip over some
Internet of
parts of it.
Things. Sounds interesting, but what does the Internet of Things actually mean? IoT is an evolution of mobile, home, and embedded applications that are being connected to the Internet, integrating greater compute capabilities and using data analytics to extract meaningful information. Billions of devices will be connected to the Internet, and soon, hundreds of billions of devices. As related devices connect with each other, they can become an intelligent system of systems. And when these intelligent devices and systems of systems share data over the cloud and analyze it, they can transform our businesses, our lives, and our world in countless ways. Whether it's improving medical outcomes, creating better products faster with lower development costs, making shopping more enjoyable, or optimizing energy generation and consumption.
All right, I'm going to cap it there. You guys can watch this rest of this on your own, and I would encourage you to do that. But the point is, small embedded devices, interconnected, generating lots of data. We can analyze that data and use it in really productive ways. For example, if you had a big office building, and I'll give you an example of one here in Milwaukee, the Northwest Mutual building in downtown Milwaukee, and that pretty brand new building. It has a lot of this type of technology built into it. In old school buildings, if they wanted to like turn all the lights off in the building, they'd have to go floor by floor and hit all the light switches. That building, they have a software panel. One guy can sit in the room, probably at home on his phone, and like, hey, let's turn all the lights off. The whole building goes off, because it's all IoT connected. Right? Crazy stuff, just that's a very simplistic example. All right, let's move on to the next slide here. All right, so there's physical parts. We have, like the Raspberry Pi that you looked at, there's things that have embedded complete computer systems in them, and all of it has connectivity, whether it's wireless or wired, but happening everywhere. Some IoT devices you might not even think about are some of the appliances in your home. Some of us have cars that are connected. A lot of us have like Ring doorbells or like other weird sensors in our house or smart thermostats. I'm just, you can go on and on and on. And more of this stuff is getting added all the time. You notice, for example, this combination of both the sensors that read the information, the computing power, and the data that it generates. Here's some really kind of interesting ones, right? Talk about smart cars and motion activated cameras, wearable blood sugar sensors, or I have like a friend who's got heart problems and he's got like a little monitor like in his chest, and it hooks up to an app on his phone. And if he ever has a cardiac event, it automatically calls 911 for him. It's just like crazy, goofy stuff like that. But that's all because of IoT. The kind of interesting thing is IoT is used in a lot of the other systems that get interconnected. And you can see like, for example, like real-time traffic information is one of those big ones. I think what is kind of weird about IoT is this concept that it's all interconnected. And I kind of want to caution on that a little bit. It's not as interconnected as you think. It's got to be configured. I do question some devices, though. For example, I have a neighbor right next door here. He's got a Ring doorbell. A lot of my neighbors are putting those in now. And in order to access the video feed on it, he's got to load an app on his phone, have an account on a server somewhere. And once again, I go back to like, who else has access to that? You can imagine the government does, right? If the police serve a warrant, they have to give up the camera feed, maybe even the data. I don't know how comfortable I am with that, right? Yeah. These are kind of weird and obtrusive, but it feels like wherever you go now, that stuff is there. Um, and they're making the connection here to the social network. Um, and what they're saying is these devices can intercommunicate, they can synchronize, they can save us time and effort. And they think of it as a social network. I don't necessarily think of it that way, but whatever. I think that this is kind of an interesting, they do this activity here. And I'm going to just do a really quick thing here. One little activity that they kind of push us to do, I'm not going to make you guys do this, but I don't know if you're like me, and I was doing this the other night when we were in Chicago, looking for a place to eat and whatever, place to park and all that kind of stuff. And of course, you like GPS where you're going, and how does your phone or your GPS know where the traffic is and isn't, where the stuff is located, where there's congestion, where there's an accident? And the reality is that all of that is driven by often either IoT devices and sensors at traffic intersections and embedded into the roadways and stuff that is out there, or by the other people also using the same services at the same time. So if we're all driving down the road, we all have our smartphone with us, location services is turned on, and then I'm using Google Maps and I'm signed into all my Google stuff. Google's reading all the data from all the other drivers that are driving the same roadways, feeding it back into a system, data analyzing it, sending it back to your phone and calculating your route just like that in real time. It's crazy stuff, right? And that's been around for a while. Like, wow. Okay. So they're kind of making out the point here that there are different types of things that drive the information and the data. So the maps apps that we're using are collecting the GPS data from our vehicles. That's satellite driven. It's not cellular or Wi-Fi driven, but it gets augmented with that. So as long as you have the location thing turned on your phone, you're being tracked, right? They know how fast your phone is going down the highway, so they can tell how congested that road is just from that data alone, right? Weird, right? So they can figure out your speed. They can figure out like, oh, anytime somebody's approaching this intersection, it's at a dead crawl or traffic's not moving here. They can pick all that up from the sensors. We get that information in our GPS apps, right? And sometimes you'll be given alternate routes. And I don't know if you guys have ever like GPS, and as you're driving, it goes, we're rerouting to save time or save fuel or whatever. And the other feature I like about it, and I don't know if you guys use this kind of a strategy. When I was driving home after that show, it was late at night. It was like bar time, late at night, and we're driving down the road. And I know how to get home. I don't need a GPS to get home, but it told me where all the police were sitting as I was driving through, right? Right. Not that I was speeding, right? I had my cruise control on, but heads up, that you're being monitored. So, be on your best behavior.
My wife's a hero for that. Every time she sees a cop, I'm like, what are you doing? And she's pulling up the app reporting for all the
Yeah.
people behind her.
Yeah, if I can manage that with my fat fingers on my phone while I'm going through, because it will pop up messages too that'll say, um, police ahead. Is this data still accurate? And you say yes. You just answer it, and you're back feeding data into the system. What blows me away is that how real time it is. That's the part I think that's really impressive. Now, they're also kind of pointing out the fact that they do look at like historical data too. So, for example, if this segment of highway is always congested during rush hour, that's pretty normal. So that will help drive some of that as well. They do kind of sync the two technologies together. And in fact, when we start to take all these disruptive technologies, you got like 5G, IoT, big data, and autonomous vehicles all working together. They all go hand in hand. I don't know if you guys are picking up on this piece. I think this is really kind of interesting. This slide is basically an imagination of headlines from the future, from 2030, if you look forward. It'd be really interesting to check it in 5 years. Now, when they put these together, it was like 2021 or something like that. So they were looking at 8, 9 years into the future. And kind of interesting. So, a billion postal deliveries signed for via augmented reality. Okay, interesting. Scientists announced breakthrough in human to machine communication. And I'm trying to read like the stuff it's saying in there. And the hackers go on the shopping spree. I think fascinating that they're doing this kind of ideation. So, headlines that will happen in the future because of the technologies that we're putting in place now. I'm not going to click into this, but this is an interesting video, right? And I would suggest that you watch it. They talk about like what the impact's going to have, 5G is going to have on society because of the increased bandwidth. And it's such a profound increase in bandwidth when you really start to study it, when you really get true 5G speeds, that it's going to enable us to do things that we never could imagine before. Once again, the reason they started doing the autonomous vehicle program at our downtown campus in Racine was because the 5G was at the lakefront in downtown Racine first. It's like and this was US Cellular doing it. And without that 5G connection, the autonomous vehicle would not be able to do what it did because it required a combination of a satellite signal for GPS and real-time data feeds from the roadways and the traffic sensors in the road. So, all right, so you can see the metrics. Sorry, meant to not click on it, but more metrics on it. Big economic impact, big impact on mobile. It already has been. The expensive part of 5G though is putting in the network, which basically in the old days when they had the 3G and the 1X networks, they used the same towers. They put up 4G on the same tower they had 3G and the 1X, right? Same technology, basically just stronger or faster bandwidths. 5G, because of its frequency, needs more access points. So where you have one big tower, you might have to have 20 little micro access points. I've noticed here in our neighborhood, we live in a kind of like a 3 block by 5 block area. We have 3 5G poles in our neighborhood alone. Right, another video here. Lower latency, better performance. I think it's self-explanatory, really. You can watch that video if you'd like to get the pep talk on it. You know, they look at kind of the transfer rates. A movie of 1 GB can be downloaded in 2 minutes on 5G. I don't know what it is. Look at the comparison chart there, right? 10 times less latency, 1,000 times more capacity, less energy usage. That's pretty impressive too. 100 times faster data rates, 100 times more connected devices. Yeah. Yeah, perception of 100% coverage. All right, so that's kind of a weird one because with lots of little micro towers, you have to have tons of them. I mean, almost like every other block or something in order to get coverage. Right? So they don't need to build big towers. Now they can just put these things on top of light poles. You know, they don't have to be up that high. I think these are really kind of an interesting metric here where they show the bandwidth needed for technology, so more bandwidth going this way, and then the amount of latency or lack of latency. By the way, 1,000 milliseconds is 1 second, right? Like if you're in a car and something's jumping in front of you, you don't want a 1 millisecond, or you don't want a 1 second delay before it decides to step on the brakes, right? You want as little as possible, like a few thousandths of a second. But notice that like autonomous driving, augmented reality, virtual reality needs to have super low latency and super high bandwidth, and that's what 5G brings. That's why it's so disruptive. When you look at like things that we kind of do, like what we're doing right now, zooming, we need bandwidth and low latency, reasonably low, a little bit's okay, just like it is for gaming. And any of the gamers here know, you get like an online game, you're looking for like the fastest ping, right? And that you're familiar with that, I'm sure. Um, in terms of how it's going to impact AI, I mean, oh my God, it's going to really kind of change everything in terms of how fast we can move that stuff around, because it does need more computing power, more bandwidth, more speed, and all that. It says the data sphere will grow by more than 5 times by 2025. So we're already there. And it's going to provide remote computing capability, like running that autonomous vehicle. Very interestingly, the autonomous vehicle called the Badger, by the way, in Racine, you can look it up if you wish. When it did like a 3-minute drive around our campus, would generate 100 gigabytes of data on a 3-minute trip. All of its sensors, cameras, and data feeds on board. One vehicle for 3 minutes. What if you had a whole fleet of them? What if all the vehicles out there, thousands of them, all at the same time are doing the same thing? So that's why we need all that capability. There is a lot of cost with 5G. When you leave the city, it's kind of not there. Maybe along the interstates and the highways, but that's about it. I mean, we have a place up north. We still get not so great cell signals up there. We're not even that far from the interstate. We do have hardwired internet, but we never run it in the winter, for example, because we're never there. So yeah, it's kind of an issue. So in the city, yeah, you can have an autonomous vehicle because we got the bandwidth to support it. Go up north, maybe not so much. So kind of an interesting thought. So now the attempt here is basically to tie up some of these concepts together. And the homework that you guys have is really kind of looking at all the disruptive technologies. So predominantly, by the way, 5G and IoT are seen as like the two big ones that are having direct effect immediately. How, when we integrate those with AI, what's going to be the result? This is really what these slides are about, so I'll let you read those. It's going to be a thing that we're going to use not only to power the systems, but also to improve the system. So we're going to use Gen AI to make these work better than they do now. And I think that, if it's done correctly, I don't know when we're going to jump up to the next level of wireless data transmission, but they're already working on it. So they are working, I don't know if they're going to call it 6G or whatever. But I think it's basically to use the same frequencies, but it's going to have even significantly higher bandwidth, but we need the infrastructure in place first. So all this stuff is coming. It's all blueprinted to be built, but we're probably looking at 10, 15, 20 years out before it's fully in place. Right? It takes a while to put the infrastructure in place. Even if we already have the technology to do it today, it takes a while to roll it out. 5G is a really good example of that. How long has that been out? 10 years? Something like that, 8 years, somewhere in that neighborhood. And it's still not available everywhere. Some of the more positive impacts, that they're looking at, like, hey, if we do this right, and we understand that there's like bias in the systems, we can program things so it doesn't have bias in the systems, that we can make things better. We can look for solutions to problems much more quickly. And we can employ those solutions more quickly as well, potentially solving problems like disease and energy and food and water and all those things that we struggle with. And we use the technology to accelerate the solutions that might otherwise take decades to determine. Um, all right. So they're comparing all of these disruptive technologies together and combining it with AI, and they're calling it the modern day Big Bang. Think about it. In the last 2 years, when you look at technology headlines, this is all they're talking about. When I go to technology conferences, this is the main topic. When we go to our state meetings for IT, for the technical colleges, last year, half the session was all about AI and data analytics, right? So if you guys don't feel like you're in the right thing, you totally are. Um, you know, they're calling it the biggest thing after social media and cryptocurrency. Um, yeah, cost effective, fast, high quality AI models for creating artifacts. I mean, we're already living it, right? Um, and holy cow, like the companies that are building this stuff have crazy market value. Crazy, crazy market value. Look the numbers on this. These are some of the bigger companies that are doing it. OpenAI, which of course is the Chat GPT parent, and their tech drives most of the other Gen AIs. Um, Tens of billions of dollars they did raising funds. That's crazy, crazy money. Crazy, crazy money. And it's not slowing down. Um, we are moving very quickly. So like the ideas really came about a long time ago. So like software based thinking machines was kind of conceived in the 50s. We had AIs back in the 90s and the teens that were already playing chess against humans and beating them, right? Like, and we're not, Kasparov is like a chess master, so like the fact that Deep Blue could beat them, it's pretty impressive. And it says Gen AI is a spaceship for the human mind, enabling new levels of creativity and innovation. I agree. I do sometimes miss like the human aspects of like working with others to be creative or physically doing something creative, like maybe generating a piece of music. But if I want to write a piece of music and I can tell the AI to create this kind of a groove for me and then I just do my magic over it, is that a bad thing? I don't know. Yes, maybe not, maybe so. I certainly don't have to hire a band then. I can just create my own music, right? So uh, kind of weird stuff like that to think about. Um, yeah, I think that we're going to see really rapid development now, because one of the things that a lot of AI developers talk about is instead of having humans work on the AI models, now we can start giving that work to the AI models themselves to work on the models. Okay, talk about mind blown. And then if you guys know programming, right? So all of you guys have taken Python and you understand what objects are and classes are. Remember, like a blueprint and then the actual thing that you create from it. And every time you create something from it, it's kind of like building a house from a blueprint. You can have a million of them. Well, who's to say that I can't take my AI, which is really smart, and then replicate it a million times and then have all million versions of that AI working on the same problem at the same time? Talk about like speeding up development. This is the kind of stuff that also freaks people out. But we are at that era, folks. The disruptive technology is here, and AI is not going away. This video ends here, by the way, so it is now over.